Section 3. Advanced System Hardening Techniques. This section will teach you how to harden a Linux system with mandatory access control, MAC, security profiles, and process isolation techniques, audit a Linux system with audit D and logging services. The section contains the following chapters. Chapter 10, Implementing Mandatory Access Control with SE Linux and AppArmor. Chapter 11, Kernel Hardening and Process Isolation. Chapter 12, Scanning, Auditing and Hardening. Chapter 13, Login and Log Security. Chapter 14, Vulnerability Scanning and Intrusion Detection. Chapter 15, Prevent Unwanted Programs from Running. Chapter 16, Security Tips and Tricks for the Busy Bee. 10. Implementing Mandatory Access Control with SE Linux and AppArmor. As we saw in previous chapters, discretionary access control, DAC, allows users to control who can access their own files and the directories. But what if your company needs to have more administrative control over who accesses what? For this, we need some sort of mandatory access control, MAC. The best way I know to explain the difference between DAC and MAC is to harken back to my Navy days. I was riding submarines at the time and had to have a top secret clearance to do my job. With DAC, I had the physical ability to take one of my top secret books to the mess decks and hand it to a cook who didn't have that level of clearance. With MAC, there were rules that prevented me from doing so. On operating systems, things work pretty much the same way. There are several different MAC systems that are available for Linux. The two that we'll cover in this chapter are SE Linux and AppArmor, and we'll look at what both of them are, how to configure them, and how to troubleshoot them. In this chapter, we'll cover the following topics: what SE Linux is and how it can benefit a system administrator, how to set security contents for files and directories, how to use such troubleshoot to troubleshoot SE Linux problems, looking at SE Linux policies and how to create custom policies, what AppArmor is and how it can benefit a system administrator, looking at AppArmor's policies, working with AppArmor's command line utilities, troubleshooting AppArmor's problems, exploiting a system with an evil Docker container. Let's start out by looking at SE Linux and how you can benefit from it. How SE Linux can benefit a systems administrator. SE Linux is a free open source software project that was developed by the US National Security Agency. While it can theoretically be installed on any Linux distro, Red Hat type distros are the only ones that come with it already set up and enabled. It uses code in Linux kernel modules along with extended file system attributes to help ensure that only authorized users and processes can access either sensitive files or system resources. There are three ways in which SE Linux can be used. It can help prevent intruders from exploiting the system. It can be used to ensure that only users with a proper security clearance can access files that are labeled with a security classification. For example, it would prevent someone with only a secret clearance from accessing top secret documents. It will also prevent someone with a top secret clearance from storing top secret documents in an area where people with lower clearance levels could access them. In addition to MAC, SE Linux can also be used as a type of role-based access control. An SE Linux role will allow the person or set of people to perform a certain assigned set of tasks, such as administering a specific type of server.
In this chapter, I'll only be covering the first of these three use cases because that's the most common way in which SE Linux is used. You'll likely never deal with the second and third use cases unless you're working for a government agency that has to safeguard classified documents. There's also the fact that covering all three of these use cases would require writing a whole book, which I don't have space to do here. If you go through this introduction to SE Linux and find that you'll still need more SE Linux information, you'll find whole books and courses on just this subject on the Pact Publishing website. So, how can SE Linux benefit the busy systems administrator? Well, you might remember when, a few years ago, news about the shell shock bug hit the world headlines. Essentially, shell shock was a bug in the bash shell that allowed intruders to break into a system and to exploit it by gaining root privileges. For systems that were running SE Linux, it was still possible for the bad guys to break in, but SE Linux would have prevented them from successfully running their exploits. SE Linux is also yet another mechanism that can help protect data in users' home directories. If you have a machine that's set up as a network file system server, a Samba server or a web server, SE Linux would prevent those daemons from accessing users' home directories unless you explicitly configure SE Linux to allow that behavior. On web servers, you can use SE Linux to prevent the execution of malicious CGI scripts or PHP scripts. If you don't need your server to run CGI or PHP scripts, you can disable them in SE Linux. With Docker and without SE Linux, it's trivially easy for a normal user to break out of a Docker container and gain root level access to the host machine. As we'll see at the end of this chapter, SE Linux is a powerful tool for hardening servers that run Docker containers. So now, you're likely thinking that everyone would use such a great tool, right? Sadly, that's not the case. In its beginning, SE Linux got a reputation for being difficult to work with, and many administrators would just disable it. In fact, a lot of tutorials you see on the web or on YouTube have disabling SE Linux as the first step. In this section, I'd like to show you that things have improved and that SE Linux no longer deserves its bad reputation. The setting security context for files and directories. Think of SE Linux as a glorified labeling system. It adds labels, known as security context, to files and directories through extended file attributes. It also adds the same type of label known as domains to system processes. To see these contents and domains on your CentOS or all Linux machines, use the Z option with either ls or ps. For example, files and directories in my own home directory will look like the following: ls-z. Processes on my system will look something like the following: ps-z. Now let's break this down. In the output of both the ls, z and ps commands, we have the following parts: the SE Linux user. In both cases, the SE Linux user is the generic unconfined U. The SE Linux row. In the ls-z example, we see that the row is object R, and in the ps-z example, it's unconfined R. The type. It's user home T in the ls-z output and unconfined T in the ps-z output. The sensitivity. In the ls/z output, it's S0. In the ps-z output, it's SO. The category. We don't see a category in the ls output, but we do see co.c1033 in the ps-z output. Out of all the preceding security context and security domain components, the only one that interests us is the type. For the purposes of this chapter, we're only interested in covering what a normal Linux administrator would need to know to keep intruders from exploiting the system, and the type is the only one of these components that we need to use for that. All of the other components come into play when we set up advanced security classification-based access control and role-based access control. Okay, the following is a somewhat oversimplified explanation how this helps a Linux administrator maintain security. What we want is for system processes to only access objects that we allow them to access. System processes include things such as the web server daemon, the FTP daemon, the Samba daemon, and the secure shell daemon. Objects include things such as files, directories, and network ports. To achieve this, we'll assign a type to all of our processes and all of our objects. We'll then create policies that define which process types can access which object types. Fortunately, whenever you install any Red Hat type distro, pretty much all of the hard work has already been done for you. Red Hat type distros all come with SE Linux already enabled and set up with the targeted policy. Think of this targeted policy as a somewhat relaxed policy that allows a casual desktop user to sit down at the computer and actually conduct business without having to tweak any SE Linux settings. But if you're a server administrator, you may find yourself having to tweak this policy in order to allow server daemons to do what you need them to do. The targeted policy, which comes installed by default, is what a normal Linux administrator will use in his or her day-to-day duties. If you look in repositories of your CentOS or all Linux virtual machines, you'll see that there are also several others, which we won't cover in this book. Installing the SE Linux tools. For some bizarre reason that I'll never understand, the tools that you need to administer SE Linux don't get installed by default, even though SE Linux itself does. So, the first thing you'll need to do on your CentOS or all Linux virtual machine is to install them. On CentOS 7, run this command: sudo yum install set tools policy core utils policy core utils python. On all Linux 8 and 9, run this command: sudo dnf install set tools policy core utils policy core utils python utils. Later on in this chapter, in the troubleshooting with set troubleshoot section, we'll look at how to use set troubleshoot to help diagnose SE Linux problems. In order to have some cool error messages to look at when we get there, go ahead and install the C troubleshoot now, and activate it by restarting the audit daemon. There's no set troubleshoot daemon because set troubleshoot is meant to be controlled by the audit daemon. Install SE troubleshoot like so. For CentOS 7, use these commands: sudo yum install SE troubleshoot, sudo service audit d restored. For Linux 8 and 9, use these commands: sudo dnf install SE troubleshoot, sudo service audit d restart. Of the little systemd quirks that we have to deal with on Red Hat type systems is that you can't stop or restart the audit d daemon with the normal systemctl command. However, the old-fashioned server command works. For some reason that I don't understand, the Red Hat folk configured the audit d service to disable the normal systemd way of doing things. Depending on the type of installation that you choose when installing CentOS or Linux, you might or might not already have CE troubleshoot installed. To be sure, just go ahead and run the command to install it. It won't hurt anything if SE troubleshoot is already there. You now have what you need to get started. Let's now look at what SE Linux can do for a busy web server administrator. Creating web content files with SE Linux enabled. Now let's look at what can happen if you have web content files that are set with the wrong SE Linux type. First, we'll install, enable, and start the Apache web server on all CentOS virtual machines. Note that including the --now option allows us to enable and start a daemon all in one single step. Do the following on CentOS 7. Sudo yum install httpd sudo systemctl enable no httpd. On all Linux, use the following command: sudo dnf install httpd sudo systemctl enable no httpd. If you haven't done so already, configure the firewall to allow access to the web server. Sudo firewall cmd permanent add service http. Sudo firewall cmd reload. When we look at the SE Linux information for Apache processes, we'll see the following: psax-z pipelined grep httpd. As I said before, we're not interested in the user or role. However, we're interested in the type, which in this case is httpd_t. On Red Hat type systems, we won't normally place web content files in the var www html directory. Let's look at the SE Linux context for that HTML directory. pwd var www ls-zd html. The type is httpd syst content, so it stands to reason that the httpd daemon should be able to access this directory. It's currently empty, so let's cd into it and create a simple index file: cd html pwd sudo vim index.html. Here's what I'll put into the file. Okay, as I said, it's simple. Since my HTML hand coding skills are what they used to be, but still it serves our present purposes. Looking at the SE Linux context, we see that the file has the same type as the HTML directory, ls/z. I can now navigate to this page from the web browser of my trusty OpenSUSE workstation, Figure 10.1, testing SE Linux. Now, though, let's see what happens if I decide to create content files in my own home directory and then move them to the HTML directory. First, let's see what the SE Linux context is for my new file. Pwd ls ls/z index.html. The content type is now user home t, which is a surefire indicator that I created this in my home directory. I'll now move the file to the HTML directory, overwriting the old file. Sudo move index.html var www.html. cd var www.html. Even though I moved the file over to the var www.html directory, the SELinux type is still associated with users' home directories. Now I'll go to the browser of my host machine to refresh the page. Figure 10.2 SELinux blocking access. So I have a slight problem. The type that's assigned to my file doesn't match the type of the HTTPD daemon process. So SELinux doesn't allow the HTTPD process to access the file. Had I copied the file to the HTML directory instead of moving it, the SELinux context would have automatically changed to match that of the destination directory. Fixing an incorrect SELinux context. Okay, so I have this web content file that nobody can access, and I really don't feel up to creating a new one, so what do I do? Actually, we have 3 different utilities for fixing this. chcon, restorecon, semanage. Let's look at each of them. Using chcon, there are 2 ways to use chcon to fix an incorrect SELinux type on a file or directory. The first is to just manually specify the proper type. Sudo chcon -t httpd syst content t index.html ls/z. We can use the chcon to change any part of the context, but as I keep saying, we're only interested in the type, which gets changed with the -t option. You can see in the ls/z output that the command was successful. The other way to use chcon is to reference a file that has the proper context. For demo purposes, I changed the index.html file back to the home directory type and created a new file within the var www.html directory, ls/z-z. As you can see, any files that I create within this directory will automatically have the proper SELinux context settings. Now let's use that new file as a reference in order to set the proper context on the index.html file. Sudo chcon //reference some file.html index.html ls-z. So I used the --reference option and specified the file that I wanted to use as reference. The file that I wanted to change is listed at the end of the command. Now that's all good, that's all to the good, but I want to find an easy way that doesn't require quite as much typing. After all, I'm an old man and I don't want to overexert myself, so let's take a look at the restorecon utility. Using restorecon. Using restorecon is easy. Just type restorecon followed by the name of the file that you need to change. Once again, I've changed the context of the index.html file back to the home directory type. This time though, I'm using restorecon to set the correct type, ls/z. Sudo restorecon index.html. And that's all there is to it. You can also use chcon and restorecon to change the context of an entire directory and its contents. For either one, just use the -r option. The following is an example. Sudo chcon -r-t httpd syst context t var www.html. Sudo restorecon -r var www.html. Remember, R stands for recursive. There's still one last thing to take care of, even though it isn't really affecting our ability to access this file. That is, I need to change ownership of the file to the Apache user. Sudo chown apache column index.html. Let's now look at the final utility, which is semanage. Using semanage. In the scenario I've just presented, either chcon or restorecon will suit your needs just fine. The active SELinux policy mandates what security context in certain directories are supposed to look like. As long as you're using chcon or restorecon within directories that are defined in the active SELinux policy, you're good. But let's say that you created a directory elsewhere that you want to use to serve out web content files. You wouldn't need to set the httpd content type on that directory and all of the files within it. However, if you use, say, hcon or restorecon for that, the change won't survive a system reboot. So to make the change permanent, you'll need to use se-manage. Let's say that for some strange reason, I want to save web content out of a directory that I created in the home directory. pwd/home, sudo webdir, ls-zd. Because I had to use my sudo powers to create the directory here, it's associated with the root user's home root T type. Instead of the normal user home the T type, any files that I create within this directory will have the same type, ls-z. The next step is to use se-manage to add a permanent mapping of this directory and the httpd syscontent T file type to the active policies content list. Sudo se-manage f context -a-t httpd syscontent T home webdir ** ls-zd. Okay, here's the breakdown of this se-manage command. F-context, because se-manage has many purposes, we have to specify that we want to work with the file context. -a, this specifies that we're adding a new record to the context list for the active SE-Linux policy. -t, this specifies the type that we want to map to the new directory. In this case, we're creating a new mapping with the httpd syscontext type, content type, home webdir **. This bit of gibberish is what's known as a regular expression. I can't go into the nitty-gritty details of regular expressions here, so suffice it to say that regular expressions is a language that we use to match text patterns. And yes, I did mean to say that, I did mean to say is instead of are, since regular expressions is the name of the overall language. In this case, I had to use this particular regular expression in order to make this se-manage command recursive, because se-manage doesn't have the -r option switch. With this regular expression, I'm saying that I want anything that gets created in this directory to have the same SE-Linux type as the directory itself. The final step is to do a restorecon -r on this directory to ensure that the proper labels have been set. Sudo restorecon -r webdir ls-zd. Yeah, I know. You're looking at this and saying, but this lr-zd output looks the same as it did after you did the se-manage command. And you're right. After running the se-manage command, the type seems to be set correctly, but the se-manage-f context man page says to run restorecon anyway, so I did. For more information on how to use se-manage to manage security context, refer to the relevant man page by entering man se-manage f context. Hands-on lab, SE-Linux type enforcement. In this lab, we'll install the Apache web server and the appropriate SE-Linux tools. You'll then view the effect of having the wrong SE-Linux type assigned to a web content file. If you're ready, let's go. Install Apache along with all the required SE-Linux tools on CentOS 7. Sudo yum install httpd se troubleshoot se tools policy core utils python. On all Linux 8 or 9, use the following command: sudo dnf install httpd se troubleshoot se tools policy core utils python utils. Activate se troubleshoot by restarting the audit-d service. Sudo service audit-d restart. Enable and start the Apache service and open port 80 on the firewall. Sudo systemctl enable now httpd sudo firewall cmd permanent add service http sudo firewall cmd reload. In the var www.html directory, create an index.html file with the following contents. View the information about the index.html file, ls-z index.html. In your host machine's web browser, navigate to the IP address of the CentOS virtual machine. You should be able to view the page. Induce an SE-Linux violation by changing the type of the index.html file to something that's incorrect. Sudo con-t temp t index.html ls-z index.html. Go back to your host machine's web browser and reload the document. You should now see a forbidden message. Use restorecon to change the file back to its correct type. Sudo restorecon index.html. Reload the page in the host machine's web browser. You should now be able to view the run page. End of lab. Now that we've seen how to use basic SE Linux commands, let's look at a cool tool that makes troubleshooting much easier. Troubleshooting with SE Troubleshoot. So you're not scratching your head and saying, when I can't access something that I should be able to, how do I know that it's an SE Linux problem? Ah, I'm glad you asked. View an SE Troubleshoot messages. Whenever something happens that violates an SE Linux rule, it gets locked in the var log audit.log file. Tools are available that can let you directly read that log, but to diagnose SE Linux problems, it's way better to use SE Troubleshoot. The beauty of SE Troubleshoot is that it takes cryptic, hard to interpret SE Linux messages from the audit.log file and translates them into plain, natural language. The messages that it sends to the var log messages file even contain suggestions about how to fix the problem. To show how this works, let's go back to our problem where a file in the var www.html directory has been assigned the wrong SE Linux type. Of course, we knew right away what the problem was because there was only one file in that directory and a simple ls-z showed what was wrong with it. However, let's ignore that for the moment and say that we didn't know what the problem was. By opening the var log messages file in ls and searching for SE alert, we'll find this message. The first line of this message tells us what the problem is. It's saying that SE Linux is preventing us from accessing the var www.html index.html file because it's set with the wrong type. It then gives us several suggestions on how to fix the problem, with the first one being to run the restorecon command, as I've already shown you how to do. Good rule of thumb to remember when reading these SE Troubleshoot messages is that the first suggestion in the message is normally the one that will fix the problem, using the graphical set SE Troubleshoot utility. So far, I've only talked about using SE Troubleshoot on text mode servers. After all, it's very common to see Linux servers running in text mode. So all of us Linux folk have to be text mode warriors, but on desktop systems or servers that have a desktop interface installed, there is a graphical utility that will automatically alert you when SE Troubleshoot detects the problem. Figure 10.3 as a Linux security alert. Click on the alert icon and you'll see something like this. Figure 10.4 as a Linux alert browser. Click the troubleshoot button and you'll see a list of suggestions on how to fix this problem. Figure 10.5 fixing the problem. Note that these screenshots are from a CentOS 7 machine, but they could look the same on either an old Linux 8 or an old Linux 9 machine. As is often the case with GUI thingies, this is mostly self-explanatory, so you shouldn't have any problem figuring it out. Troubleshooting in permissive mode. If you're dealing with a simple problem, like the one I've just shown you, then you can probably assume that you can safely do what the first suggestion in this SE Troubleshoot message tells you to do. But there will be times when things get a bit more complex, when you might have more than one problem. For times like these, you need to use permissive mode. When you install your Red Hat, CentOS or Linux system, SE Linux is in enforcing mode, which is the default. This means that SE Linux will actually stop actions that are in violation of the active SE Linux policy. This also means that if you have multiple SE Linux problems when you try to perform a certain action, SE Linux will stop the action from taking place after the first violation occurs. When it happens, SE Linux won't even see the remaining problems and they won't show up in the messages log file. If you try to troubleshoot these types of problem while in enforcing mode, you'd be like the proverbial dog who chases its own tail. You'll go round and round and will accomplish nothing. In permissive mode, SE Linux allows actions that violate policy to occur, but it will log them. By switching to permissive mode and doing something to induce the problem that you were seeing, the prohibited actions will take place, but SE Troubleshoot will log all of them in the messages file. This way, you'll get a better view of what you need to do to get things working properly. First, let's use get enforce to verify what our current mode is. Sudo get enforce. Now let's temporarily place the system into permissive mode. Sudo set enforce 0. Sudo get enforce. When I say temporarily, I mean that this will only last until you do a system reboot. After reboot, you'll be back in enforcing mode. Also, note that a 0 after set enforce denotes that I'm setting permissive mode. To get back to enforcing mode after you're done with troubleshooting, replace the 0 with a 1. Sudo set enforce 1. Sudo get enforce. We're not back in enforcing mode. At times, you may need to make permissive mode persist after system reboot. An example of this would be if you ever have to deal with a system that has had SELinux disabled for a long period of time. In a case like that, you wouldn't want to just put SELinux into enforcing mode and reboot. If you try that, it'll take forever for the system to properly create the file and directory labels that make SELinux work, and the system might lock up before it's done. By placing the system into permissive mode first, you'll avoid having the system lock up, although it will still take a long time for the relabeling process to complete. To make permissive mode persistent across system reboots, you'll edit the SELinux file in the etc systconfig directory. Here's what it looks like by default. The two important things you see here are that SELinux is in enforcing mode and that it's using the targeted policy. To switch to permissive mode, just change the SELinux line and save the file. The SE status utility shows us lots of cool information about what's going on with SELinux. Sudo SE status. The two items that interest us here are the current mode and the mode from a configuration file. By changing the configuration file to permissive, we haven't changed the current running mode, so we're still in enforcing mode. The switch to permissive won't happen until I either reboot the machine or until I manually switch by using a sudo set enforce 0 command. And of course, you don't want to stay in permissive mode forever. As long as you no longer need permissive mode, change the configuration file back to enforcing and do sudo set enforce 1 to change the running mode, working with SELinux policies. So far, all we looked at is what happens when we have an incorrect SELinux type set on a file and what to do to set the correct type. Another problem we may have would come about if we need to allow an action that is prohibited by the active SELinux policy. Viewing booleans. Booleans are part of what makes up an SELinux policy, and each boolean represents a binary choice. In SELinux policies, a boolean either allows something or it prohibits something. To see all booleans on your system, run the get -bool-a command. It's a long list, so it will only show partial output here. Get -bool-a. To view more than one boolean, the -a switch is mandatory. If you just happen to know the name of the boolean that you want to say, leave the -a out and list it. In keeping with the Apache web server theme that we had going, let's see whether we're allowing Apache to access files and users' home directories. Get -bool httpd enable home dirs. The fact that this boolean is off means that the Apache server daemon isn't allowed to access any content within the user's home directories. This is an important protection, and you really don't want to change it. Instead, just put web content files elsewhere so that you don't have to change this boolean. You rarely want to look at the entire list, and you likely won't know the name of the specific boolean that you want to see. Rather, you probably want to filter the output through grep in order to look at just certain things. For example, to see all of the booleans that affect a web browser, do this. Get -bool-a pipe grep httpd. It's also a rather long list, but scroll down a little and you'll find the boolean that you seek. I'm only able to show you different examples for using SELinux, but you can get a more complete idea of what SELinux either can protect or is already protecting by using the output of the get -bool-a command. Now let's configure some booleans. Configuring the booleans. Realistically, you'll likely never have reason to allow users to serve up content out of their home directories. It's much more probable that you'll set up something like a Samba server, which would allow users on Windows machines to use the graphical Windows Explorer to access their home directories on Linux servers. But if you set up a Samba server and don't do anything with SELinux, users will complain about how they don't see any of their files in their home directories of the Samba server, because you're a proactive type and you want to avoid the pain of listening to complaining users. You'll surely just go ahead and configure SELinux to allow the Samba daemon to access users' home directories. You may not know the exact name of the boolean, but you can find it easily though, as follows. Get -bool-a pipe grep home, Okay, you knew that the Boolean name probably had the word home in it, so you filtered for that word. About halfway down the list, you say the Samba enabled home doors off. You need to change this to on to let users access their home directories from their Windows machines. Sudo set sebul Samba enable home doors on. Get sebul Samba enable home doors. Users can now access their home directories as they should be able to, but only until you do a system reboot. Without the -p option, any changes you make with set sebul will only be temporary. So let's make the change permanent with -p. Sudo set sebul -p Samba enable home doors on. Get sebul. Congratulations, you've just made your first change on an SE Linux policy. Protecting your web server. Look at the output of get sebul-a, grep http command again, and you'll see that most HTTPD related booleans are turned off by default, with only a few turned on. There are 2 of them that you'll commonly need to turn on when setting up a web server. If you ever need to set up a website with some sort of PHP-based content management system, such as Joomla or WordPress, you may have to turn on the HTTPD unified boolean. With this boolean turned off, the Apache web server won't be able to interact properly with all the components of the PHP engine. Get sebul HTTPD unified off. Sudo set sebul-p HTTP unified on. The other boolean that you'll commonly need to turn on is the HTTPD can send email boolean. If you never need a website to send email out through a form, or if you need to set up a mail server with a web-based frontend, you'll definitely need to set this to on. Get sebul HTTPD can send email, HTTPD can send email off. Sudo set bool-p HTTPD can send email on. On the other hand, there are some booleans that are turned on by default, and you might want to consider whether you really need them turned on. For example, allowing CGI scripts to run on a web server does represent a potential security risk. If an intruder were to somehow upload a malicious CGI script to the server and run it, much damage could occur as a result. Yet, for some bizarre reason, the default SE Linux policy allows CGI scripts to run. If you're absolutely certain that nobody who hosts websites on your server will ever need to run CGI scripts, you might want to consider turning this boolean off. Get sebul HTTPD enable CGI. Sudo set sebul-p HTTPD enable CGI off. Protecting network ports. Each network daemon that's running on your system has a specific network port or set of network ports assigned to it, on which it will listen. The etc services file contains a list of common daemons and their associated network ports, but it doesn't prevent someone from configuring a daemon to listen on some non-standard port. So without some mechanism to prevent it, some sneaky intruder could potentially plant some sort of malware that would cause the daemon to listen on a non-standard port, possibly listening for commands from its master. SE Linux protects against this sort of malicious activity by only allowing daemons to listen on certain ports. Use semanage to look at a list of allowed ports. Sudo semanage port-l. This is yet another of those very long lists, so I'm only showing partial output. However, let's narrow things down a bit. Let's say that I only want to look at a list of ports on which the Apache web server can listen. For this, I'll use my good friend grep. Sudo semanage port-l pipe grep HTTP. Several HTTP items come up, but I'm only interested in the HTTP port T item because it's the one that affects normal web server operation. We'll see here that SE Linux will allow Apache to listen on ports 80, 81, 443, 488, 8008, 8009, 8443, and 9000. Since the Apache server is one of the few daemons for which you ever have a legitimate reason for adding a non-standard port, let's demo with it. First, let's go into the etc httpd.conf file and look at the port on which Apache is currently listening. Search for listen and you'll see the following lines. Listen 80. I don't have the SSL bundle installed on this machine, but if I did, I would have an SSL.conf file in the etc httpd.conf directory with this line, listen 443. So for normal, non-encrypted website connections, the default configuration only has Apache listening on port 80. For secure, encrypted website connections, Apache listens on port 443. Now let's go into the httpd conf file and change listen 80 to a port number that SE Linux doesn't allow. For example, port 82, listen 82. After saving the file, I restart Apache to read in the new configuration. Sudo systemctl restart httpd. Yes, I have a problem. I look in the varlog messages file to see if SE troubleshoot gives me a clue. The first line of the message details how SE Linux is preventing HTTP from binding to port 82. The first suggestion we see for fixing this is to use SE manage to add a port to the list of allowed ports. So let's do that and then look at a list of Apache ports. Sudo SE manage port -A82-T HTTP port T-P TCP. Sudo SE manage port -L pipe grep HTTP port T. It's not clear in the SE troubleshoot message, but you need to specify the port number that you want to add after port -A. The -T port HTTP port T part specifies the type for which you want to add the port, and -P TCP specifies that you want to use that TCP protocol. Now for the moment of truth. Will the Apache daemon start this time? Let's see. Sudo systemctl restart httpd. It works. We have achieved coolness, but now I've decided that I no longer need this oddball port. Deleting it is just as easy as adding it. Sudo SE manage port -D82-T HTTP port T-P TCP. Sudo SE manage port -L pipe grep HTTP port T. All I had to do was to replace port A with port T, and of course I still need to go into the etc http httpd conf file to change the listen 82 back to listen 80. Creating custom policy modules. Sometimes you'll run into a problem that you can't fix either by changing the type or by setting a boolean. In times like these, you need to create a custom policy module, and you'll use the audit to allow utility to do that. Here's a screenshot of a problem I had several years ago when I was helping a client set up a post-fix mail server on CentOS 7. Figure 10.6 using audit to allow. So for some strange reason that I never understood, SE Linux wouldn't allow dovecart, the mail delivery agent, MDA component of the mail server, to read its own dict file. There's no boolean to change, and there wasn't a type problem, so SE Troubleshoot suggested that I create a custom policy module. It's easy enough to do, but you'll need to be aware that this won't work with sudo on your normal user account. This is one of those rare times where you'll just have to go to the root user command prompt, and you'll also need to be in the root user's home directory. Sudo su dash. Before you do it, be sure to put SE Linux into permissive mode and then do something to induce the SE Linux error. This way you'll be sure that one problem isn't masking others. When you run the command to create the new policy module, be sure to replace mypol with a custom policy name of your own choosing. In my case, I named the module dovecart dict, and the command looks like this: grep dict varlog audit log pipe audit to allow -m dovecart dict. I'm using grep to search through the audit log file for SE Linux messages that contain the word dict. I then pipe the output of that into audit to allow and use the -m option to create a custom module with the name dovecart dict. After I created the new policy module, I inserted it into the SE Linux policy like so. SE module -i dovecart dict.pp. There was also a second problem that required another custom module, but I just repeated this procedure to produce another module at a different name. After I got all of that done, I reloaded the SE Linux policy in order to get my new modules to take effect. SE module -r. With the SE module, the -r switch stands for reload rather than recursive, as it does with most Linux commands. With all of that done, I put SE Linux back into enforcing mode and exited back to my own user account. And I tested the setup to make sure that I had fixed the problem. Of course, you also want to bear in mind that you don't want to just modify SE Linux policy or context every time you see an SE alert message in the log files. For example, consider the snippet from the messages file of my Oracle Linux 7 machine, which I set up mainly to run Docker and the Docker containers. Docker -1. SE troubleshoot. These messages were caused by an early version of Docker trying to access resources on the host machine. As you can see, Docker is trying to access some rather sensitive files, and SE Linux is preventing Docker from doing so. With Docker and without some sort of Mac, it can be a trivial matter for a normal and privileged user to escape from the Docker container and have root user privileges on the host system. Naturally, when you see these sort of messages, you don't want to automatically tell SE Linux to allow the prohibited actions.
It just may be that SE Linux is preventing something truly bad from taking place. Be sure to get your copy of the SE Linux coloring book from opensource.com/business1311 SE Linux Policy Guide. Hands-on Labs SE Linux Booleans and ports. In this lab, you'll view the effects of having Apache try to listen on an unauthorized port. View the ports that SE Linux allows the Apache web server daemon to use. Sudo se manage port -l grep http. Open the etc httpd conf httpd.conf file in your favorite text editor. Find the line that says listen 80 and change it to listen 82. Restart Apache by entering the following. So it systemctl restart httpd. View the error message you receive by entering sudo tail-20 var log messages. Add port 83 to the list of authorized ports and restart Apache. Sudo se manage port 83. -t http port t-p tcp sudo se manage port -l sudo systemctl restart httpd. Delete the port that you just added. Sudo se manage -t82 t http port -p tcp. Go back to the etc httpd conf httpd.conf file and change listen 82 back to listen 80. Restart the Apache daemon and restart to normal operation. End of lab. Okay. You've seen how SE Linux can protect you against various bad things and how to troubleshoot things that go wrong. Let's turn our attention to AppArmor. How AppArmor can benefit a systems administrator. AppArmor is the Mac system that comes installed with the SUSE and the Ubuntu families of Linux. Although it's designed to do pretty much the same job as SE Linux, its mode of operation is substantially different. SE Linux labels all system processes on all objects such as files, directories, or network ports. For files and directories, SE Linux stores the labels in their respective inodes as extended attributes, as an inode is the basic file system component that contains all information about the file except for the file name. AppArmor uses path name enforcement, which means that you specify the path to the executable file you want AppArmor to control. This way, there's no need to insert labels into the extended attributes of files or directories. With SE Linux, you have system-wide protection out of the box. With AppArmor, you have a profile for each individual application. With either SE Linux or AppArmor, you might occasionally find yourself having to create custom policy modules from scratch, especially if you're dealing with either third-party applications or homegrown software. With AppArmor, this is easier because the syntax for writing AppArmor profiles is much easier than the syntax for writing SE Linux policies. And AppArmor comes with utilities that can help you automate the process. Just as SE Linux can, AppArmor can help prevent malicious actors from ruining your day and it can help protect user data. So you see that there are advantages and disadvantages to both SE Linux and AppArmor, and a lot of Linux administrators have strong feelings about which one they prefer. To avoid being subjected to a flame war or refrain from stating my own preference. Also note that even though we're working with an Ubuntu virtual machine, the information I present here, other than the Ubuntu specific package installation commands, also work with the SE Linux distros. Looking at AppArmor profiles. To begin, we'll install the LXC package so that we can have more to look at. Sudo apt install LXC. In the etc AppArmor.d directory, you'll see the AppArmor profiles for your system. SE Linux folks say policies, but AppArmor folks say profiles. ls-l. All of the text files you see in this directory are AppArmor profiles. If you've installed the LXC package, you'll find a few other profiles in the XLC and XLC container subdirectories. Still though, there's not a whole lot there in the way of application profiles. For some reason, a default installation of OpenSUSE comes with more installed profiles than Ubuntu server does. To install more profiles in Ubuntu, just run this command: sudo apt install AppArmor-profiles, AppArmor profiles extra. In the abstraction subdirectory, you'll find files that aren't complete profiles, but that can be included in complete profiles. Any of these abstraction files can be included in any number of profiles. This way, you don't have to write the same code over and over every time you create a profile. Just include the abstraction file instead. If you're familiar with programming concepts, just think of abstraction file as include files by another name. Here's a partial listing of the abstraction files. To get a feel for how AppArmor rules work, let's peek inside a web data abstraction file. This file is just a list of directories from which the Apache daemon is allowed to read files. Let's break it down. Note that each rule ends with R. This denotes that we want Apache to have read access to each listed directory. Also note that each rule has to end with a comma. Sev www.htdocs R. This means that the listed directory itself has read access for Apache. Save www.htdocs **r. The *** wildcats make this rule recursive. In other words, Apache can read all files in all subdirectories of the specified directory. #mod userdir, if installed, this Apache module allows Apache to read web content files from a subdirectory that's within a user's home directory. The next two lines go along with that. At home public HTML_r and at home public HTML_r column. The at home variable allows this rule to work with any user's home directory. You'll see this variable defined in the etc app_armor.d tunables home file. Note that there's no specific rule that prohibits Apache from reading from other locations. It's just understood that anything that's not listed here is off limits to the Apache web server daemon. The tunables subdirectory contains files that have predefined variables. You can also use this directory to either define new variables or make profile tweaks. Space doesn't permit me to show you the details of how to write your own profiles from scratch. Thanks to the suite of utilities I will look at in the next section, you might never need to do that. Still, just to give you a better understanding about how AppArmor does what it does, the following is a chart of some example rules you might find in any given profile. Now that you know about AppArmor profiles, let's look at some basic AppArmor utilities. Working with AppArmor command line utilities. Whether or not you have all the AppArmor utilities you need will depend on which Linux distro you have. On my OpenSUSE Leap workstation, the utilities were there out of the box. On my Ubuntu server virtual machine, I had to install them myself. Sudo apt install AppArmor utils. First, let's look at the status of AppArmor on the Ubuntu machine. Since it's a rather long output, we look at it in sections. Here's the first section, sudo AA status.
The first thing to note here is that AppArmor has an enforce mode and a complain mode. The enforce mode that's shown here does the same job as its enforcing mode counterpart in SE Linux. It prevents system processes from doing things that the active policy doesn't allow, and it logs any violations. Now here's the second section. Complain mode is the same as permissive mode in SE Linux. It allows processes to perform actions that are prohibited by the active policy, but it records those actions in either the file log audit log file or the system log file, depending on whether you have audit D installed. Unlike Red Hat type distros, audit D doesn't come installed by default on Ubuntu. You would use complain mode either to help with troubleshooting or to test new profiles. Most enforce mode profiles we see here have to do with either network management or with LXC container management. Two exceptions we see are the two profiles for NapD, which is the daemon that makes the snap packaging technology work. The third exception is the MySQLD profile. Snap packages are universal binary files that are designed to work on multiple distros. Snap technology is currently available for most of the major Linux distros. Currently, when you install a daemon package on Ubuntu, you'll sometimes get a predefined profile for that daemon, and sometimes you won't. Even when a profile does come with the package that you've installed, it's sometimes already in enforce mode and sometimes isn't. For example, if you're setting up a domain name server and you install the bind9 package for it, you'll get an AppArmor profile that's already in enforce mode. If you're setting up a database server and install the MySQL server package, you'll also get a working profile that's already in enforce mode. But if you're setting up a database server and you prefer to install the MariaDB server instead of MySQL server, you get an AppArmor profile that's completely disabled and that can't be enabled. When you look in the usr-sbin MySQLD profile file that gets installed with the MariaDB server package, you'll see this. Okay, so apparently AppArmor isn't good for everything, and whoever wrote this needs to take spelling lessons. And then there's Samba, which is a special case in more ways than one. When you install the Samba package to set up a Samba server, you don't get any AppArmor profiles at all. For Samba and several other different applications as well, you need to install AppArmor profiles separately. Sudo apt install AppArmor profiles extra. When you install these two profile packages, the profiles will all be in complain mode. That's okay, because we have a handy utility to put them into enforce mode. Since Samba has two different daemons that we need to protect, there are two different profiles that we'll need to place into enforce mode. ls*mbd. We'll use AA
AA-enforce to activate enforce mode for both of these profiles. Sudo AA-enforce USR sbin nmbd sudo AA-enforce USR sbin smbd. To use AA-enforce, you first need to specify the path to the executable file or the process that you want to protect. Fortunately, you normally won't ever even have to look for that up, since the path name is normally part of the profile. Use file name. The last part of the command is the file of the profile. Note that you'll need to restart the Samba daemon to get this ARPAMA protection to take effect. Placing a profile into other modes is just as easy. All you have to do is to replace the AA-enforce utility with the utility for the mode that you need to use. The following is the chart of utilities for the other modes. Okay, we're moving right along. You'll now know about setting basic ARPAMA commands. Next up, we'll look at troubleshooting ARPAMA problems. Troubleshooting ARPAMA problems. When I wrote the first edition of this book back in 2017, I sat there racking my brains for several days, trying to come up with a good troubleshooting scenario. It turns out that I didn't need to. The Ubuntu fork handed me a good scenario on a silver platter in the form of a buggy Samba profile. At the time, I was working with Ubuntu 16.04, which had the original version of the bug. The original bug got fixed on Ubuntu 18.04, but was replaced by two others. In Ubuntu 22.04, the profile is finally bug-free. I still want to show you how to troubleshoot ARPAMA problems though, so I've left the 16.04 and 18.04 write-ups intact. It's still possible to download and install Ubuntu 16.04 and 18.04, so you can create some virtual machines to follow along if you like. I'll leave that decision up to you. Troubleshooting with an ARPAMA profile, Ubuntu 16.04. As you've just seen, I used AA-enforce to put the two Samba-related profiles into enforce mode, but watch what happens when I try to restart Samba in order to get the profiles to take effect. Sudo systemctl restart smbd. Okay, that's not good. Looking at the status for the smdb service, I see this. Sudo systemctl status smbd. The important things to note here are all the places where some form of the word fail shows up. The original error message said to use journalctl -xe to view the log message. You can do that if you like, or you can just use either less or tail to look in the syslog log file. So we see ARPAMA equals denied. Obviously Samba is trying to do something that the profile doesn't allow. Samba needs to write temporarily files into a run Samba message.log directory, but it isn't allowed to. I'm guessing that the profile lacks a rule that allows that to happen. But even if this log file entry gave me no clue at all, I could just cheat using a troubleshooting technique that has served me well for many years. That is, I could just copy and paste the message from the log file into my favorite search engine. Pretty much every time I've ever done that, I've found that other people before me have already had the same problem. Figure 10.7, looking up an ARPAMA error message. Okay, I didn't paste in the entire error message, but I did paste it in enough for DuckDuckGo to work with. And lo and behold, it worked. Figure 10.8, DuckDuckGo search results. It looks like my profile file might be missing an important line, so I'll open a USR sbin smbd file and place this line at the end of the rule set. Run samba **rw comma. This line will allow read and write access to everything in the run Samba directory. After making the edit, I need to reload this profile because it's already been loaded with the AA-enforce. For this, I'll use the ARPAMA parser utility. Sudo ARPAMA parser use a sbin smdb. All you need to do is use the -r option for reloading and list the name of the profile file. Now let's try to restart Samba. Sudo systemctl restart smbd. Sudo systemctl status smbd service. And it works. The two Samba profiles are in enforce mode and Samba finally starts up just fine. The odd part about this is that I had the same problem with both Ubuntu 16.04 and Ubuntu 17.10, so the bug has been there for a long time. Troubleshooting an ARPAMA profile, Ubuntu 18.04. As I said before, the bug can 1604 got replaced with two others in 1804. So let's look at that. I installed Samba and the additional AppArmor profiles on my Ubuntu 1804 VM, and let's set the two Samba profiles into enforce modes the same way that I've already shown you for Ubuntu 1604. When I tried to restart Samba, the restart failed. So I looked in the var log syslog file and found these two messages. Now that we know how to read the AppArmor error messages, it's easy to figure it out. It looks like we need to allow this SMBD service to have net admin capability so that it can properly access the network. And it looks like we also need to add a rule to allow SMBD to write to the run systemd notify socket file. So let's edit the etc AppArmor d, use bin SMBD file, and add the two missing lines. First, in the stanza with all the capability lines, I'll add this line to the bottom, capability net underscore admin. Then at the bottom of the rules list, just under the var spool samba star read write line, I'll add this line, run systemd notify rw. It's now just a matter of reloading the policy and restart SMBD service, the same as we did for Ubuntu 1604. Hands-on lab troubleshooting an AppArmor profile. Perform this lab on an Ubuntu's 1804 VM. Carry out the following steps for troubleshooting. Install the AppArmor utilities and the extra profiles. Sudo apt install AppArmor utils, AppArmor profiles extra. Install Samba and verify that it's running. Sudo apt install Samba, sudo systemctl status smbd, sudo systemctl status nmbd. Set the two aforementioned Samba policies to enforce mode and try to restart Samba. cd etc AppArmor-d, sudo aa enforce usr sbin smbd, usr sbin smbd, sudo aa enforce usr sbin nmbd, usr sbin nmbd, sudo systemctl restart smbd. Know that Samba should fail to restart. It will take a while. It will take quite a while before it finally errors out. So be patient. Look in the var log syslog file to see if you can spot a problem. Edit the etc AppArmor-d usr sbin smbd file in the capability stanza. Add this line, capability net admin. At the bottom of the rule section, under the var spool samba star read w line, add this line, run systemd notify read w. Save the file and reload the policy. Sudo AppArmor parser -r usr sbin smbd. As before, try to restart the Samba service and verify that it started properly. Sudo systemctl restarts smbd, sudo systemctl status smbd. End of lab. Okay, you've just explored the basics of troubleshooting buggy AppArmor profiles. This is good knowledge to have, especially when your organization needs to deploy some custom profiles that could end up being just as buggy. Troubleshooting Samba problems in Ubuntu 22.04. I told you before that the buggy AppArmor profile for Samba has been fixed in Ubuntu 22.04, so hallelujah for that, right? Well, not that fast. As I'm writing this in November 2022, there's now a bug in certain versions of Samba that prevents Samba from starting if the AppArmor profile is enabled. This bug was also in SUSE 15.3, but has been fixed in SUSE 15.4. It also had been fixed in Ubuntu 22.10. By the time you read this, it might also have gotten fixed in Ubuntu 22.04. First, install the Samba AppArmor profiles, AppArmor profiles extra, and AppArmor util packages, as I described in the preceding sections. Doing a systemctl status smbd command should allow that the Samba service is running normally. Next, we'll set the two Samba profiles to enforce mode. cd etc AppArmor-d, sudo aa enforce usr sbin smbd, usr sbin smbd, sudo aa enforce usr sbin nmbd, usr.sbin nmbd, sudo systemctl restart smbd. This time, you won't see an error message until you do systemctl status smbd. Systemctl status smbd. Unlike before, searching through the system log file won't tell you anything. If you search through the usr sbin smbd file, you see no problems at all. Instead, the problem this time is with the print service function of this ARMOR service. Fortunately, it's an easy fix as long as you don't mind going without Samba print sharing. Just open the etc samba smb.com file in your text editor and add the following line to the global section. Disable spool ss equals yes. The Samba service should now start up without issues. Now I have to confess that I don't know what the exact impact of this directive will be. The smb conf page says that printing might be impacted for Windows NT 2000 systems, but it doesn't say anything about how it affects newer versions of Windows. At any rate, I'll leave this experimentation up to you if you really need Samba print server support.
Alright, enough of the Samba business. Let's move on to something that's evil but also fun. Exploiting a system with an evil Docker container. You might think that containers are somewhat like virtual machines, and you'd be partially correct. The difference is that a virtual machine runs an entire self-contained operating system, and a container doesn't. Instead, a container comes with the guest operating system's package management and libraries, but it uses the kernel resources of the host operating system. That makes containers much more lightweight. So you can pack more containers on the server than you can virtual machines. Which helps cut down on hardware and energy costs. Containers have been around for quite a few years, but they didn't come all that popular until Docker came on the scene. But the very thing that makes containers so lightweight, the fact that they use the host machine kernel resources, can also make for some interesting security problems. Using some form of Mac is one thing that you can do to help mitigate these problems. One problem is that to run Docker, a person needs either to have a proper suite of privileges or be a member of the Docker group. Either way, anyone who logs into a container will be at the root command prompt for that container. By creating a container that mounts the root file system of the host machine, a non-privileged user can take complete control of the host system. Hands-on lab creating an evil Docker container. To demonstrate, I'll use the CentOS 7 virtual machine in order to show you how SE-Linux can help protect you. I'm using CentOS 7 because the RHEL 8.9 type distros use Podman instead of Docker, which won't allow this exploit to happen. Also, you need to do this from the local console of the VM because the root user will be locked out from logging in via SSH. You'll see what I mean in just a bit. On your CentOS 7 VM, install Docker and enable the daemon. Sudo yum install Docker, sudo systemctl enable now Docker. Create a Docker group. Sudo group add Docker. Create a user account for Caitlin, my teenage calico kitty, adding her to the Docker group at the same time. Use sudo user add just Docker Caitlin, sudo password Caitlin. Log out of your user account and log back in as Caitlin. Have Caitlin create a Debian container that mounts the /partition of the host machine in the /home root mount point, and that opens a bash shell session from the root user. Docker run -v home root it Debian bash. Note how Caitlin has done this without having to use any sort of privileges. Also note that there are no blank spaces in the home root part. The goal is for Caitlin to make herself the root user on the host machine. In order to do that, she'll need to edit the etc password file to change her own user ID to 0. To do that, she'll need to install a text editor. Caitlin prefers Vim, but you can use Nano if you really want to. While still within the Debian container, run the following: sudo apt update, sudo install vim. Have Caitlin cd into the host machine's etc directory and attempt to open the password file in the text editor. cd home root etc vim password. She won't be able to do it because SE-Linux prevents it. Type exit to exit the container. Log out from Caitlin's account and then log back into your own account. Place SE-Linux into permissive mode. Sudo set and force 0. Log out of your own account and log back in as Caitlin. To repeat steps 5 through 7. This time Caitlin will be able to open the etc password file in her text editor. In the password file, have Caitlin find the line for her own user account. Have her change her user ID number to 0. The line should now look something like this. Save the file and type exit to have Caitlin exit the container. Have Caitlin log out of the VM and then log back in. This time you'll see that she has successfully logged into the root user shell. End of lab. Okay, you've just seen one of Docker security weaknesses and how SE-Linux can protect you from it. Since Caitlin doesn't have sudo privileges, she can't put SE-Linux into permissive mode, which prevents her from doing any Docker mischief. On the RHEL 8.9 type distros, things are even better. Even with SE-Linux in either permissive mode or completely disabled, you still won't be able to edit the password file from within a container on either of your Linux machines. That's because RHEL 8.9 and their offspring use Podman, which is Red Hat's drop-in replacement for Docker. Podman has several advantages over Docker, mainly in the area of host machine security. So now you're wondering if AppArmor on Ubuntu helps us with this. Well, not by default, because there's no pre-built profile for the Docker daemon. When you run Docker on an Ubuntu machine, it automatically creates a Docker profile on the container in the tmpfs directory, but it really doesn't do much. I tested this procedure on an Ubuntu 18.04 VM with AppArmor enabled, and Caitlin was able to do her evil did just fine. Note that Podman is also available for non-Red Hat Linux distros, including Ubuntu. Earlier in this chapter, I said that I would refrain from stating which of these two Mac systems I prefer, but I lied. If you haven't figured it out by now, I'm definitely a big fan of SE Linux because it provides better out-of-the-box protection than AppArmor does. If you choose to use Ubuntu, then plan on writing a new AppArmor profile anytime that your development team deploys a new application. If you'd rather not deal with the complexities of creating AppArmor profiles, you can instead place security directors in the systemd unit files for your services. You might find that this is a bit easier and can give you much of the same protection that AppArmor would. To read all about it, check out my other books, Linux Service Management Made Easy with Systemd. I do believe that this wraps up things for your discussion on Mac. Summary. In this chapter, we'll look at the basic principles of Mac and compare two different Mac systems. We saw that what SE Linux and AppArmor are and how they can help safeguard your systems against malicious actors. We then looked at the basics of how to use them and the basics of how to troubleshoot them. We also saw that even though they're both meant to do the same job, they work in vastly different ways. We wrap things up by showing you a practical example of how SE Linux can protect you from evil Docker containers. Whether you're working with AppArmor or with SE Linux, you always want to thoroughly test the new system in either complaint or permissive mode before you put it into production. Make sure that what you want to protect gets protected, while at the same time what you want to allow gets allowed. After you place the machine into production, don't just assume that you can automatically change a policy setting every time you see a policy violation occur. It could be that nothing is wrong with your Mac setup and that Mac is just doing its job protecting you from the bad guys. There's a lot more to both of these topics that we can cover here. Hopefully though, I've given you enough to whet your appetite and help you out in your day-to-day duties. In the next chapter, we'll look at more techniques for hardening the kernel and isolating processes. I'll see you there. Questions. Which of the following would represent a Mac principle? You can set permissions in your own files and directories however you need to. You can allow any system process to access whatever you need it to access. System processes can only access whichever resources Mac policies allow them to access. Mac will allow access even if DAC doesn't. How does SE Linux work? It places a label on each system object and allows or denies access according to what SE Linux policies say about the labels. It simply consults the profile for each system process to see what the process is like to do. It uses extended attributes that an administrator would set with the chatter utility. It allows each user to set his or her own max. Which of these utilities would you use to fix an incorrect SE Linux security context? Chatter, ch context, restore cons, set se ball. For an all day-to-day administration of a Red Hat type server, which of the following aspects of a security context would an administrator be most concerned about? User role type sensitivity. You've set up a new directory that a particular daemon wouldn't normally access, and you want to permanently allow that daemon to access that directory. Which of the following utilities would you use to do that? chcon, restore con, set cbo, se manage. Which of the following constitutes one difference between SE Linux and AppArmor? With SE Linux, you have to install or create a policy profile for each system process that you need to control. With AppArmor, you have to install and create a policy profile for each system process that you need to control. AppArmor works by applying a label to each system object, while SE Linux works by simply consulting a profile for each system object. It's much easier to write a policy profile for SE Linux because the language is easier to understand. Which etc AppArmor subdirectory contains files with predefined variables? tunables. Variables var functions. Which of the following utilities would you use to enable an AppArmor policy? enforce, enable, set enforce, set enable. You already enabled an AppArmor policy for a daemon, but you now need to change the policy. Which utility would you use to reload the modified policy? A reload, AppArmor reload, a restart, AppArmor parser. You're testing a new AppArmor profile and you want to find any possible problems before you place the server into production. Which AppArmor mode would you use to test that profile? Permissive, enforce, testing, complaint. Further reading, SE Linux access in SE Linux policy documentation, using SE Linux. For SE manage commands to keep SE Linux in enforcing mode. SE Linux system administration, 3rd edition. SE Linux policy for Pi-hole, SE Linux coring book. Linux server management made easy with systemd. AppArmor. Ubuntu AppArmor wiki. How to create an AppArmor profile. The comprehensive guide to AppArmor. Samba printing server bug. Answers 1C, 2A, 3C, 4C, 5D, 6B, 7A, 8A, 9A, 10D.